some of the cleavage components of the complement cascade system that we've not discussed that just kind of float off and do other things are covered in your book as well. They begin discussing it on page 182. Some are called anaphylaxitoxins. Anaphylotoxins are actually going to stimulate release of histamine from cells. So these fragments that float away, like the C3A component, for example, or the C5A component, they kind of drift away and they can bind to receptors on the surface of granulocytes and cause degranulation, which can stimulate more of an inflammatory response. The C3B and C4B can bind and facilitate opsonization. So when they're bound to a bacterium, it dramatically increases the phagocytic activity toward those bacteria or viruses. My analogy is powdered sugar on donuts. The complement system can also neutralize viruses by binding to specific structural proteins on the virus. If that protein happens to be necessary for the infectivity of the virus, then it can block infection into the cells. Trying to think, there's Newcastle's is listed, Epstein-Barr is listed. That's just a few of them. So you can get complement, I guess you would say, complement system immunity against certain viral strains. You can get interference with the binding of complement to antibody-antigen complexes. That can occur. That's one of the ways that viruses have used as a strategy to avoid being seen by the immune system. So they produce a protein or something that will prevent the complement cascade from binding to the FC region, that stem region, some of those constant regions on the bottom part of the two heavy chains. And it'll prevent those antibody-antigen complexes from being recycled. Well, ask yourself what that does. If you're not recycling those antibodies aren't out there to bind another virus. So if they release these proteins that prevent them, then it kind of neutralizes the activity of antibodies in the vicinity that have already reacted with antigens. Okay? So you're a virus. You infect along with a couple 100,000 of your buddies, and the immune system starts attacking. Some of the soldiers grab one of your buddies, and he's going to take it over to the phagocyte and recycle. Well, if you can stop him from recycling, he can't come back out and attack you. That's kind of the theory behind it. Viral mimicry of mammalian complement regulators. Some of these actually have proteins that can bind to the specific subunits of the complement cascade that would normally bind as regulators or cofactors on the surface of normal immune cells. So they compete for binding sites. Keep them bound up so they won't be binding the ones that stimulate an effect. And last, they can incorporate cellular complement regulators in the viral particle itself. Human leukemia virus is one that incorporates salicylic acid in its viral envelope. It makes the virus deactivate the complement regulators on the surface of the cells. Many of your cells have salicylic acid on the surface, sialic acid on the surface of their membranes, and this neutralizes the complement cascade, thus preventing it from being able to push forward. Let me say that a little more clearly. Sialic acid actually denatures and speeds up the degradation of certain complexes, like the C3 complex is degraded much more quickly if sialic acid is in the membrane. So these viruses have just duplicated one of the control mechanisms that we use. complement system clears immune complexes from circulation. If if this is not done, then you can have a lot of autoimmune diseases coming up. They believe this is one of the things that happens with lupus. Systemic lupus is a disease usually where you have antibodies against your own DNA. So as a cell dies, it releases little fragments of DNA to which certain antibodies can bind to. Well, if you could keep those cleared using an effective complement cascade system, then it prevents the antibodies from reacting and causing inflammatory responses and cell-mediated responses in the area. So systemic lupus actually causes random damage throughout the entire body, entire system, and can cause inflammatory responses and cell-mediated responses, necrosis, all sorts of problems. So one of the ways they're trying to treat that is they're trying to come up with serum to which they can add kind of, how would I say this, a generic complement system to it in order to help clear the, give every 6 months, give a transfusion containing these components, and then it helps to clear the antibodies that are bound to your own DNA from the system and lower the levels of effectors that can attack the red blood cells. The last little segment in this chapter is complement deficiencies, and I'm going to let you read that one on your own. It's interesting, but I don't think I could say anything on here that would make it any easier to understand. Just read it.